Today, we will be looking at one of the SEER 3D solutions in a little bit more detail. So today we'll be looking at machining. So if I go into the model and select this one. So what we have is the ability to import a model. So you can click on here. Past projects will appear in the list here, or you can browse in a traditional way to find the step file that you need to estimate. So I'll just cancel that one, stick with this one. So let's have a look at the buttons. So the structure is over here, and this is going to be the WBS. Now, it doesn't look impressive at the moment because it's just a single item. It's not an assembly or something more complicated as that. You have cost inputs, which is this one over here, and that will become populated once we start selecting the process. So this is a machined part. It's going to be turned, and now you can see we've started to populate it. So we'll look for a stainless steel turn lathe 4, and now we have some inputs to consider looking at. So coming down through the list, I've selected a random environment, so it's a lathe turn one. So that set this one to lathe milling. We need to tell it always the quantity and the batch size. So enter 25 there. What is the origin of the material? Now, this is the same input as you would have in native SEER for manufacturing. Is it a forging, a casting, a sand casting, investment casting, or does it come from an additive manufactured item? It's raw stock. It's whatever material you want it to make it from. So I've got more materials in here than the standard model. So we'll select a stainless steel, and it's going to be round solid, or it could be round tube. So that will then adjust, as you can see, the bounding box here. So we're having close fit. Now you may wish to adjust this. So you would say my outer diameter may be from a 500 mil piece of bar. So if it's at 40 in here, I've got more to turn off, but it's a stock size. Maybe it's 475, something like 15. And as you can see, I'm adjusting this to a stock size standard bar. The length is adding on 18.25. Now you'll see the model turn. Now all I'm doing is clicking on the screen and moving my mouse left to right with the left mouse pin held down. Okay, so we can move things around. If I put the structure on and it's still okay, we can see it. We can zoom in, we can zoom out now. You can do this by rolling the mouse button if you have a roller on your mouse, or you can hold down the shift key and move your mouse up and down the page. So I'm holding the shift key and moving up and down the page. If I want to zoom in on a particular area, I can click on this little one here, fit area. Red cross appears, zoom in. Then you need to remember to uncheck it, because what happens is, I've zoomed in too far. So uncheck it to remove that cross, and then you can look at this area. Next to this one, we can measure. So what do I want to measure? I want to measure a diameter. I can click on that, and you'll see we have dimensions there being interfered with by the graphic, but it's 21 mil hole, and so on. So again, measure, diameter, or clear, and then that gets rid of that once again. If you have a big rectangular part or something awkward, if you hold down the control key, you can move it left to right. So I'm holding down my control key, I'm moving this part around left, right, up, down, based upon my mouse movement. So that's how we manipulate it. Now, you've probably opened yours and you've got a green screen. This is done under things like options. So we can change our screen colors, make it far football team, and click on OK, top color, let's choose something random. So it's pretty garish, very bright. Probably you'll want to work in a more traditional color scheme. So we'll just quickly change it to something more vanilla. There we go. So still quite bright. But that's all you need to do. Now, the model uses these manufacturing environments that I selected over here. And this is the path to where it resides. Now you can move that path and you can reset it here by browsing and navigating to the relevant location. So this is in its normal place. So this is the SEER 3D manufacturing environment, which you'll find in C, users, public, and in the SEER folder. The license directory, this is where the license and most of the files that control SEER reside. So they're in the program files. You can switch between imperial and metric. The model has an auto save function you can enable or disable. I tend to leave it on. It can become annoying if you've got a large part and it keeps reloading it and resaving it, but it does give you that factor of safety. So this is the folder where it will save your save sessions. And then we have other features here about analytical feature recognition. So if you come in with a part that isn't correctly drawn, there's some gaps in it, you can remove that. If you want split multi-body parts, you can do that one. You can display a ghost image of the part on the system. And you can display instance names if the model has been drawn with instances. So that's all that is there. So on to what we have on the general input tabs over here. So the model doesn't set a quantity, but it does set a setup size. So if this was 200, click on OK. This can be set in the environment to be a percentage of that, or it can be a fixed number. Likewise, the material will set these defaults for you: raw stock, stainless steel, titanium, whatever you need it to be. Now, there are advantages by having material-specific environments, lathe bore, stainless steel, because then it allows you, when it comes to finishing, to allow you to capture the relevant processes. Like you don't want to anodize the steel, you want to zinc plate it, for example, and magnetic flaw detect steel and glow penetrant aluminium. So that sort of thing it does for you. Raw shapes and lathe milling are all set by the environment, and that's because I chose a turning option. These are optional that are set by the environment. So in the environment, this is saying deburr, yes, finishing heat treatment, yes, tooling, no. We can turn tooling back on. We can turn finishing heat treatment off if we wish to include or exclude deburring. You can enter a length factor. So if you don't think this length is representative of what it is because of all of the holes or whatever you need to do, you can add additional length there. The 6,000, and it will give you that little bit more, 11% more to the factor. These are part properties extracted from the geometry of the part. Weight is a function of its volume and the material choice and the density of that material held in the system. The volume is calculated based upon the part and all of its shapes. The weight, volume, again calculated based upon the bounding box size and the material density and area weight. And then the volume is here. This is the volume to be removed. And that's what's going to be used in these calculations in the next tab. So in this one, there's going to be some volume rough turning. It's going to take off this much. Now that's a controlled percentage of the overall volume, again, controlled by the environment. Same with detailed roughing, volume rough boring, no detailed. There's no milling on the spark, so they're cancelled out, nothing to take out. You can leave it like that, or you can just shut them down and it won't do anything to it. And likewise, there's no sawing up called for. So that's how we're going to rough it out. And so you can see the shadow of the part now has appeared. Finishing operations. So now we have all of the surfaces that are color coded. So we'll have a look at this one. And it's telling us turn finish, 0.1 tolerance. It's going to be that one and that one. So it's just drawn in two parts. But we can say I need to have more tighter tolerance on these faces, and that will cover that now. So this will add additional time and processes to it. Likewise, this one is a bore finish. And again, we'll increase the tolerancing on it so that these two areas here are covered. And you can go around and do that. In the future release, the information relating to sizes will be taken care of. So you won't have to do that. The rules will take care of tight tolerances, will add grinding ops, and diameters will have grinding ops if necessary. So we'll just have a look at some of these in here. You can zoom it in and rotate my mouse, click on this one, and add that same tolerance of this one. Bottom of the groove, close that one, all that face there, and again, change that. So that's what we do for that one. And you can do that, you can exclude faces. So if you say this is not going to be machined, it's found it here, you can turn that off. Face will disappear from the list, and you'll see the inside, the back of the undercuts that we have in here as well. So quite often you won't need to do that, but in some cases where you're using a casting or a forging, there may be finishes or faces that do not need finishing in the machining process. They may be left in their raw state. All of these could be tighter limits, and again, we could change them accordingly. Then we come to the holes, clicking on the holes, and again, we can identify which holes is which. And if nothing lights up, come down the list and you'll see them are all here. So this one is this one. So all I want to do is I want to make these tapped. So again, threading, tap, click on OK. Now they'll all be tapped. And we're ready. So we've gone through the general tab. We've entered our material type, our batch sizes. We've selected an environment. Considered the bounding box size, how much we're going to remove. We've looked at the finishing operations. We deleted the ones that weren't necessary. We've included the faces. We've modified the tolerancing on some of these, which we deemed needed closer limits. And the holes, they're all one set of holes. So we've set them to be tapped, and we're ready to go. So that's what we need to do. Click on estimate over here, and we can click on estimate in this box here, or the big box at the top for estimates. And here we go. So we're estimating that. So this is creating a file now in SEER for manufacturing. It's going to add all of the turning operations required to produce this part based upon the environments and the changes we made from the environment settings, tapped holes, and so on. There we go. We have our estimate. So we have our machining ops. So that material wasn't in the list, so we'll just change that to stainless steel. Click on OK. Producing 200, batch of 25, labor rates and everything will be set by the environment. The important one is here. So in this one, if we go to view, click on machining, I've just collapsed all of the operations here, so they're no longer showing. And you can see quite quickly, done a lot of rough turning, detailed turning, turning faces, boring diameters. And here you'll see our holes are all tapped. We added that. And all the same here. So these are the faces we increased the tolerancing on. So they've added cylindrical grinding operations. Remember the operation details report. Click on that one. And you can see the time required for all of these processes. And we can go back to this one here, and we can save the session. If we're not quite finished, we have to go to lunch, we have to have further considerations, we're waiting for information, we can click on save, and it will save you a environment. I'll just stick it on the desktop for now, and I'll give it a name, part X. And okay, we'll save it. So we can go back now, and we can come back to our import and look at the list. And you'll see now we can pull in the glance strut, which is this part here. And so if I click on this one, so I'll just bring in the wrong part, and then I'm going to browse again, and I can bring in my session file. I'm now going to bring that in with everything set up to the point at which we set it. We've got our tapped holes already set, our surface finish operations have been captured, our tighter tolerancing on these two as well. So that's the importance of a session file. So that's all I wanted to show you today. So the general interface, some of the things we can look at and do, manipulating it across the screen, holding down the shift key, moving it left or right, up and down, measuring, fitting all to the screen, fitting into an area, and all of those types of things, zooming in and out with the mouse. So thank you very much. That's all we need to show you today. And that is SEER 3D for machining. And once again, thank you very much for your time and attendance.